Yo 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 yo. Alright, guys, sup students. So today we're gonna be going over combinations, permutations, partitions, and whatever else these have in store for us. So first of all, okay, what are permutations? Right? You're asking, what are permutations? Well, permutations are when you organize a certain type of group. Let's say you have three things, right? Circle, square, and triangle, square, circle. And you want to order these in, you want to see how much ways you can order this. Like, yeah. So, I mean, well, you could have triangle first, or you can have square first, or circle first. That is 3 ways you can put the first slot. But once you choose that one, then you get 2 and then 1, because if you have triangle in the first slot, you can't put triangle in the second or first slot, the third slot, right? So if you times all of these, that would be how much permutations there are, because each, like, let's say square and circle, each of them have 2 of these. So like three of them have, each of them have 2 possibilities. So triangle has 2 possibilities, square has 2 possibilities, circle has 2 possibilities. 3 times 2, that's 6. That's what permutations are, and here's the formula, which is NPR is equal to n factorial over n minus r factorial, where r is the thing, when p is permutations, when n is total amount of objects, and r is the r is the number of things you choose. Yeah, the number of chosen elements in the set. Total number of elements, number of chosen elements, and p, permutations. Alright, so how do we do this problem? Or first, what is a factorial? What is the symbol? Right? So when you have n factorial, where like whatever, it's n times n minus 1, n minus 2, all the way to 1. So let's say you have 3 factorial. You start with 3, then you do 3 minus 1, 2, and then 3 minus 2, which is 1. You stop at 1, right? That's basically what a factorial is. It's pretty simple, actually. And you might be wondering, what is 0 factorial then? Because, I don't know what 0 factorial is. I'm joking. 0 factorial is equal to 1. Because you know why? Factorials are how much ways you can like order something. That's what permutations and whatever this are. Like how much sets you can make. Like say you have 2 factorial. That means you have 2 total elements or 2 total objects. Let's put them on the table. let's label this A, label this B. 2 total objects, and 2 factorial. 2 factorial is 2, right? That's how many ways you can order A and B. So you can order A and B as A first, B second, or you can have B first and A second, right? Same goes with 1 factorial. If you have 1 factorial, there's 1 object you can order, A, and that means there's only 1 possible thing you can order it, because it's the only object. And 0 is the same thing as 1, where there's only 1 object of nothing, and you can order that only 1 time, 1 way. Now let's go on to the problems, right? So determine the number of all 4-digit natural numbers in decimal notation where the digit 0 is not present, and each of the remaining 9 numbers occurs at most once. Okay, let's draw this out. Let's draw the slots out. 4 number places, thousands, hundreds, tens, and ones, right? 4-digit natural numbers in decimal notation where the digit 0 is not present, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. These are all the numbers that you can put in a single slot, because if you put 10, well, that's not a number that you can put in a single place, right? Digit 0 is not present. You cannot use 0 at all, so you cross out 0. Each of the remaining 9 numbers occurs at most once. So let's say in the first slot you can choose either 1, 2, 3, 4, 5, 6, 7, 8, or 9. That means 9 possibilities. However, you must cross out, like let's say you chose 4 in the first slot. You can only have 1, 2, 3, 5, 6, 7, 8, or 9 in the second slot, right? That's 8. Like, let's say you can't choose 4 in the second slot because you already chose 4. Now you choose like 6, right? Cross out 6. And that would mean 1, 2, 3, 5, 7, 8, 9, 7. Same goes until you have run out of slots, right? 9 times 8 times 7 times 6. Now, what is that equal to? 9 times 8 times 7 times 6, that is equal to 3,024 possibilities, right? But Devin, wait, what about the simpler problems? I don't want to jump straight into permutations. Well, here's a simple one, right? So how many outfits can you make if you have 3 different hats, and 4 different shoes? Well, because each hat can have each of shoes, like each hat could have either this set, this shoes, this shoes, this shoes, or this shoes. That mean that 1 has 4, and same with this, and same with this, right? Or when you start with the shoes, like each of them can have 1 times 3, 1 times 3, 1 times 3, and 1 times 3, and you add these all together. This is 3 times 4, and this is 4 times 3. That is the basic counting principle, right? And if you add another pair of set, you can multiply that by that as well, which is pretty easy, right? Okay, now moving on. How many committees of 5 students can be selected from a class of 25? Well, this is a combination problem, so let's see what combinations are. So n combination r, where r is the chosen elements, n is the number of elements. So it's n factorial, r factorial, n minus r factorial. It's very similar to permutations, however, there is another part, right? You might be wondering what n minus r and what is all this in the bottom if n factorial is like 5 students ordered differently. Like this n factorial is like 5 times 4 times 3 times 2 times 1, right? Choosing 5 students in a permutation. Then what is this? What is n minus r and r factorial? Well, that is where you have to eliminate choices, right? So let's look at this problem. Okay. Since there is how many committees of 5 students? 1, 2, 3, 4, 5 students. Committees, right? We're class of 25. Right? Okay, so each slot could have 25 or 24 or 23. Now 22 and 21. Right? So basically, what n minus r factorial is basically the r is the amount of slots you have, right? And how much total things, like since you have 25 students, it goes on from 20 to beyond. That's why you do 25 minus 5, because you're not using the rest of the 20 that goes on. This is the amount of slots, right? So how many committees of 5 students can be selected from class of 25, right? Let's say all of this is, the permutation. However, r factorial, this, what does that do? Gosh. What this r factorial means is how much of these are redundant. Like when you do these permutations, how much permutations of the combinations are redundant. What redundant means is how much of these permutations are actually the same combination. Because what combinations are, right? It's basically you choose a set of objects, right? Let's say circle, triangle, square, right? Circle, triangle, square. If you put circle here, triangle here, these are two separate permutations, but a singular combination, because these are the same objects, but these are this different order, right? Get it? So to find the amount of combinations, committees, because each student you choose does not matter if they are in a committee. What their name is does not matter. What their status is does not matter. What matters is which combination you choose, right? So 25 times 24 times 20 times 22 times 21. You divide this by how much ways these can be redundant. So it's 1 way, 2 way, 3 way, 4 way, 5 way. There's 5 slots, 5 factorial ways. So let's do this. 25 times 22 times 23 times 22 times 21 divided by 5 factorial. This is 53,150 combinations. Okay, now let's move on. Okay, so now that we know how we do slots and the formulas, we're gonna use either one, right? So let's say we have 4 different colored candies. How many ways can you choose 2 candies from these 4? So you choose 2, right? So now this would be 4 objects you choose. Then it's 3. How many ways can you order these around? That's 2 factorial. 4 times 3 over 2 factorial, right? Or you can do this, like since there's 4 total objects, over R, you choose R and then choose this again. what is this equal to? So 4 factorial is equal to 4 times 3 times 2, which equals to 24. And then 2 times 2, 2 times 1 times 2 times 1, that's 4, that's equal to 6. Or you can do 12 over 2, which equals 6 as well. Okay, how many 7-digit TOEFL numbers can be formed if the first digit cannot be 0 or 1? Let's write this out, because there's 7 digits. 1, 2, 3, 4, 5, 6, 7, right? And there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the numbers, right? However, if the first digit cannot be 0 or 1, let's see. Cannot be 0 or 1 for the first digit right here. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities, right? But now, after the first digit, you can use all of these numbers, right? So there's a total of 10 numbers, and because it doesn't really say it's like a permutation, combination, or like you cannot use a number again, all of the rest of these are all 10, right? So it's 8 times 10 to the power 1, 2, 3, 4, 5, 6. 8 to the power of 10 to the 6. That is the answer. Okay, how many different 5-digit street addresses can have the digits 47348? Okay, let's put this into our thing. 5 digits. Or, let's see, this is a permutation, right? Rather, whatever. Since there's 5 digits and you're choosing 5 digits, 5 minus 5, 0 factorial 1. So let's use the permutation formula, right? 5 total things, 5 minus 5 factorial. So 5 factorial over 0 factorial, 5 factorial over 1. This is 5 factorial, right? This is 5 factorial. And the same with this, like, let's see, there's 5 digits, 4 digits, 3 digits, 2 digits, and 1 digit, right? That's 5 factorial. However, because 4 and 4 are over here, that means, like, let's say if 4A and 4B are over here, if they exchange, that is the same permutation, right? So to remove that redundancy, you divide it by 2 factorial, because that's how many ways you can order 4A and 4B. And yeah, so 5 factorial divided by 2 factorial, that's 60 permutations. Okay, let's see here. A pizza shop offers 7 different toppings. You want to order a pizza with exactly 3 toppings. How many different combinations of toppings can you choose? So it's a combination problem, right? So there's 7 different toppings, 7 factorial. You order exactly 3 toppings, so 7 minus 3 factorial is 4 factorial. So that would be that. How many different combinations of toppings can you choose, right? So that would be 6, 1, 2, 3. So that would be 7, 6, and 5 over 3 factorial, because these are combinations, they can switch around, and this is the same as this, because 4 factorial is over here, you cross that out, and 765 divided by 3 factorial. Guess what? What is 7 times 6 times 5 divided by 3 factorial? That's 35 combinations. 3 distinct hardcover books and 5 distinct paperbacks are placed on the shelf. And how many ways can the books be arranged if all the hardcover books and the paperbacks must be together? So basically what this is asking is if all the hardcover books are together and all the paperbacks are together. And how many ways can you arrange this on a bookshelf? So that means, right, all the hardcover books are within each other, right, with each other, and all the paperbacks must be together as well, right? However, because that they could switch things, they could switch places, that is 2 factorial ways you can order it, first of all. But if each of these are distinct, right, you could order it how many ways, you know, as well. So that's 3 factorial. Same with the paperbacks, 5 factorial. I don't think you can use any of these formulas. Oh, you can use permutation formula right here to choose things. You know how that works. So 2 times 6 times 120. 1,440 ways that they could be arranged. How many permutations are there of the word school? Okay, permutations, right? There are 1, 2, 3, 4, 5, 6 letters. And you want, and then how many permutations are there? 0, O, and O are repeating, so that's 2 factorial. So that would be 6 times 5, that's 4 times 3. 360 permutations. Okay, now this is a tricky problem. Make all arrangements of letters of the word Tamil so that T is always next to L, T and L are always together. Right, let's draw this out. Because there are 5 letters, there are, that much things. However, because T is always next to L and T and L are always together, they combine to make a single element. So that's TA. So that's TL. So now there are 4 elements. Right? 4 elements. So now combine these two slots. Now there's 4 slots because there's 4 elements. Right. So let's see. Now that there's 4 elements, that is 4 factorial. And since T and L can be swapped, because it's a kind of combination sort of thing. No, permutation. Because it's a permutation problem. Then it's 4 factorial over 2 factorial, which is 4 times 3. That's 12 ways you can order it. Okay, so this is an even harder problem. A math team has 8 members. They want to form a team of 3 people to go on their next competition. However, 2 members who are best friends insist on either both being on the team or neither of them being on it. How many different ways can the teams be formed? So first, let's find out how many that could go if this wasn't a thing, right? If the best friends didn't care. Let's see, so using the combination formula, it's 8 factorial over 3 factorial over 5 factorial. So that's equal to 8 times 7 times 6 divided by 3 factorial. That's 56 combinations. Right? But now, because like they're asking us insist on either both being on the team or neither of them being on it, let's see how many ways that can be formed. So if they were on it, let's say we chose like person A, best friend A. Okay, let's do this. Maxim and Kaden, they're best friends, insist on either being on the team or being on it. Let's say they chose M first, and then one of the 6 peoples that are not on it, and K, Kaden. Let's see. So because this is isolated, that is 6 ways that they can be chosen, right? 6 ways to be chosen. And 6 factorial ways to be chosen. Now you're choosing because M and K are together, I'm choosing two peoples, right? So 6 minus 2 factorial, 6 factorial over 2 factorial, 4 factorial. What is this then? X times 5 divided by 2. Why does this work? Why does this work? Why does this work? Because 6 factorial ways you can order the other people. 2 factorial ways, 4 factorial ways of them not being on a team, and 2 factorials. I'm not sure, which equals 15. And if they're not on the team, let's see what happens. Not on the team, the same thing. You choose 2 different people. I don't know. And that's another 15, so times 6 plus 15. It's 30. 56 minus 30 is 26. I'm not really sure on why this one works, but you know what. Okay, so everyone decides to split his delicious batch of 12 identical chocolate chip cookies among the rest of the math team board. G 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, among the math team board, Adir, Eric, Daniel, Orly, Bruno, Henry's. Can you do this so that every person, including everyone, gets 1 cookie? So there's 6 people, right? So 6 people, they each get 1 cookie. So first of all, they each get 1 cookie. 1, 2, 3, 4, 5, 6. Right? They each get 1 cookie. 1, 2, 3, 5, 6. Now there's 6 cookies left over. How many ways can you partition them? Since like either like one person can get all 6 of them, or like they can split it evenly. That's where the stars and bars and partitions come in to play, right? Let's see the stars and bars like formula. So it's n plus k minus 1 over n, where k is the amount of groups that it goes to, k minus 1 is the amount of bars, because the bars separate how much cookies each person gets, n as the total number of cookies, total number of elements. Okay, now let's put it in, right? So let's say a deer gets 3 extra cookies, Bruno gets 1 extra cookie, and Air Hunt gets 2. And how much do the other people get? Well, they get none, none, none. Well, so let's see now. Because the bars are a part, like, of the thing, a part of the elements, that's why this formula works. Let's see now. 6 plus k minus 1. So 6 groups minus 1 is 5 over 6. Right? Oh baby. Oh baby. What the heck? Okay. Okay. Now when you do this, right, there's 11 total elements, 6 plus 5 bars, over the n, there's 6 cookies. Plug this into the combination formula, is 6 factorial over 11 factorial, which is equal, oh my god, oh my god, oh my god, what is this? Oh my god, oh my god, oh my god, which is equal to 462 ways that he could split the rest of the cookies. Okay, so now finally, this is my last problem that I have. Math City has 8 streets, all of which are straight. No street is parallel to another street. One police officer is stationed at each intersection. What is the greatest number of police officers needed? So, let's see. So, there's 8 streets, right? So, 8 streets, right? We're gonna do the choose 8, choose something, right? Because each intersection is an intersection is based off of 2 streets crossing, and because no street is parallel, that means 8 choose 2. Each 2 is how much we're choosing from the 8 and how much they gain, how much intersections they get. Plug this into the thing. Now you get 6 factorial, 2 factorial over 8 times 7 divided by 2 is 28 intersections. Okay, class, I hope you learned a lot from me. Wait, but hold on. I think maybe there's more. Hold on. Nope. I am not doing multinomial theorem. So, guys, I hope you enjoyed watching this long ass video and going through every problem with me. I hope you learned a lot. Okay? And I'll see you in the next time. Devin out. Oh shit.